kind of. You guys don't have mics, so you're close enough to my mic or you talk loud enough to be able to hear you. Okay, so to change the negative exponent to positive, you relocate it. If it starts at the top, you relocate it down to the denominator. And that would make it a positive 7. So this would really be 1 over b to the positive 7. Okay, let me show you mathematically what we're really doing. You don't have to do this every time. Why this mathematically works. B to the negative 7. I like that you said over 1, right? Even though I did under 1. Over 1. What we're really doing is timesing by a fancy form of 1. We do this later on in the year too. A fancy form of 1 is anything divided by itself. Would you agree that b to the 7th divided by b to the 7th is technically 1?
Yeah.
Anything divided by itself is 1? And we learned the product rule last time, and we just did this wrap. When dealing with these exponents and the base is the same, that's important. Do these both have b's for the base? When we multiply exponents, we do what? Multiply?
Add.
Multiply? Add. Good. And negative 7 plus 7 is what? 0.
Boom.
And in the denominator, 1 times b to the 7th is just b to the 7th. Now last time we learned the 0 property. B to the 0 is not just nothing, it is 1. So 1 over b to the 7th. That's why this shortcut works. The shortcut is circle it and move it. Change it and change the sign. So you don't have to do it mathematically like that every time. That's to show you why it works. Okay, let's try another example. Example 2. 1 over c to the negative 14. Try it yourself really quick. Give it some thought. See what you think would happen. Remember, we're trying to make these all positive exponents. We can't have negative exponents or zeros in our answer. No, you don't have to do the mathematical way. We just did that one time. Okay? Someone from the back row, maybe over there. How would we go about making the c to the negative 14 a positive? Anyone in the back row have an idea? Johnny, do you know? No? What about the back row over here? You got it? It's not really flipping. Well, I guess you can think of it as flipping. But you have to be careful about flipping. Because if this was like a 4 up there, you can't just flip it. Because the 4 doesn't go in the denominator. So we're going to circle the whole thing and move it up.
Oh,
And
so
notice the c is circled with it. And now that I wrote the 4, I'll just keep the 4. 4 stays in the numerator. C to the good positive 14. Do we need to write over 1? No, we don't have to. Oops. You can, but you don't have to.
Wait, so we're changing it to a 4 now?
Yeah. Because I added the 4. Okay. Does anyone in here have a 3-letter name? Last one. Sure, a nickname is 3 letters. A cat that has 3 letters.
I have I.
Ned.
What?
I-K-E,
I-K-E?
yeah.
Okay. Example 3.
Ned.
Notice I write it all with lowercase because variables are lowercase. Okay, there's our example. Oh, just kidding, I need some exponents, don't I? Let's put some exponents on. Okay, what about...
Put 48.
Is that a question? Yeah. Yep, so on the numerator it says 7i to the 4th, k to the negative 2e, divided by 28, j to the negative 8, o, that's a 1, h to the 1st power, n to the negative 9th power. So, what we need to do is make sure everything's positive. You see one that's not positive, please raise your hand. Okay, which one's not positive? Give me one example. On the k. So k is negative 2. So we have to take both of those, and not just the negative 2, not just the k, both of them together, and where do they go? On the bottom. On the bottom. They're going to go down. Okay, any others? Raise your hand, please. And it was Queenie, yes? J to the negative 8th power. To make that positive, where do we move it? Up. Excellent. Okay. Others? Others? Yes? Your name again? Fernando. 9, or n to the negative 9? Yep. Where does that go, Fernando? Yeah. Okay. Now, when we grade, generally my answers are written in alphabetical order. So let's figure out what goes on the top and try to put it in alphabetical order if we can. Okay, up on top, what would be our first letter in alphabetical order? E. Yeah, E. If you want, let me do this first. E's stay on the top, right? I and E stay on the top. And what are the two that we moved up? J and N. And when we move it, it's going to become positive 8, and the N will become positive 9. I'm going to do it this way first, and then we can worry about alphabetical order. In the denominator, O to the 6th, H to the 1st, we're already there. And what goes down? Yeah, K, and it will be positive second, right?
Wait.
Well, now we're going to do alphabetical order. Yeah, I decided to show the intermediate step. Okay, alphabetical order. I, E, J, or N? E. What is E's exponent? It's 1. It is something. It's 1. After E comes I to the 4th, then J to the 8th, then N to the 9th. Good. In the denominator for the variables, what was your name in the front? Tony. Can you tell me the alphabetical order for our variables in the denominator? Then what comes after H? A squared and? Good. Now, what do we do with these? Do we divide, subtract? Divide, subtract? Divide. We just divide them. These are called coefficients. So they follow what's between them. This fraction bar means divide. Please show me your fingers in the air. What is 7 divided by 28? What is 7 divided by 28? You have 7 pizzas for 28 people to eat. 7 pizzas for 28 pizzas or people to eat. It is? Right?
No.
Why is it not 4? What's 4? Yeah, it's not. The numerator is smaller, so it's not 4. Is that a question, or are you still working on the 1/4? Okay. 1/4. So be careful. That's why I ask those a lot, because sometimes we do our division in the wrong order. Make sure you're dividing 7 divided by 28. We don't have enough pizza for everyone to have their own. So they're going to have a partial amount, which is 1/4. Could I just do it like this and not write the 1? Could I do it like this and not write the 1?
No, you write the 1.
We can leave it like this. You can write the one if you want.
But that's like good.
You can write it there if you want. You can write this one if you want, and this one if you want, but all those that I just did in green, they don't have to be there. But you can write them if you want. Any questions on negative exponents? Okay, let's do the power rule then.
Do we draw a line?
If you want. Example 4. Okay. 2 times s squared a times m cubed, all that quantity raised to the 4th power.
So that,
Oh.
is that a 5 or is that an N?
This is an s. This is, yes, this is Sam. Do you know how to do this? Okay, tell me how to do it. There's a couple different ways you can go about doing this one. So, is it Madison? No, I'm not even close. What? McKenna. Okay, one sec. Looks like we have a note coming in. Kara. I need to go to the council center. That's right behind you. Okay, McKenna. How would you do this problem?
My teacher called it addition method, where you multiply to the 4th power to everything in the middle. And we do
So, like, distributing it in?
yeah.
Okay, yes, this is one way you can go about doing it. Yes,
What's that button?
don't push it, it's red.
What does it do?
I think it's like
Goes
where
to
she
the office.
talks to the office.
It's emergency button.
Like, so if you're sick, you press that and you go to the office?
No, I press it if there's an emergency.
If I get in a fight it out.
Okay. I'm sure your junior high has that. Okay. One way to do this problem, and you have to, I'm going to show you 2 methods. You pick which method is more comfortable for you. One way is to take the exterior exponent and distribute it to everything inside, but some people forget to distribute it to that 2, so be very careful. So the 2 will be raised to the 4th power. The s squared would be raised to the 4th power. See that? Double steps there. The a is raised to the 4th power. Does the a actually have an exponent?
Yeah.
The 1, right? You can write the 1 if you want, but you don't have to.
And then that's it.
You can just do a to the 4th.
Um,
And the
9.
cubed raised to the 4th power. Then, does anyone remember from the way McKenna's doing it, how we would do the next step?
You add all the exponents.
Yeah.
Times. Good.
Oh.
This is not the product rule. Product we add. When you have a double exponent, you times. Okay? Is this 2 an exponent? No. What's that word? Coefficient. Good. So you do not times 2 times 4. Instead you do 2 to the 4th power, which is 2 times 2, which is 4, times 2 is 8, times 2 is 16. And then s, 2 times 4 is 8. A, 1 times 4 is 4. For the n, 3 times 4 is 12. Any questions on this method before I show you a second way to do the same problem?
Which one's easier, you think, for?
You have to figure that out for yourself, because some people think this is easier, some people think the other one is easier. Okay, well let me show you the exact same problem in the second way. An example for part 2. This 4 is your copy machine. That exterior exponent is the number of copies. So this one could get tedious if that number gets really big. So it means we have 4 copies of the parentheses. So isn't that what exponents are? Or just repeated multiplication? It's just repeating this, multiplying it together. And there's 4 of them.
You really have to write 4 of them?
Just this one time you do. Oh my gosh, I do this 4 times every 2 days, so you only have to do it once. So this one can become more complicated when that exterior exponent gets large. And the idea is what we do from here if we extend it out into the 4 copies. Fernando, can you take the earbud out, please?
You put them together.
Think about what we've done, actually, it's not on the top of your notes. On your last notes, what did we do on your last notes? What does this become? From your last notes. Add them, because what rule is it that we learned last time? Multiply, add, multiply, add. That has a name. What is it? Product rule. This becomes the product rule. So whenever you have, remember the wrap? Dealing with these exponents, and the base is the same. So I'm just going to look at the S's, because those have to be the same bases. There's too much talking going on. When we multiply with the same base, we multiply, multiply, multiply. Good. 2 plus 2 plus 2 plus 2 is 8. Now we do the common base, 8. 1 plus 1 plus 1 plus 1 is 4. Then we do the ends. Take common like term by like term. 3 plus 3 plus 3 plus 3 is 12. Now, I heard someone say, don't forget the coefficient. Well, do we add these guys? Because they're not exponents, right? You said it. We have to do what? Multiply. 2 times 2, 4 times 2. Thanks for humoring us with that. Anyway, it comes out the same, right? 16 is matched. Is matched, right?
Yeah.
Okay. So, I'm showing you 2 ways. Pick which way you like to do best and stick with that. This second way gets tedious if that outside exponent's large. Okay, let's try another power rule before we finish these notes. Okay, first person to think of their favorite sport that has no repeated letters in the name. Rugby, okay.
I won them.
And in the red shirt, give me your favorite number.
Cricket.
Keep it kind of small for us.
8.
8. Okay, thank you. Rugby. Mr. I don't think, does Cotton even have a rugby team?
No, they don't play for Skyline.
Oh.
But I'm playing for Olympics.
Okay, Mr. New Science teacher this year. Lard, yeah, he plays rugby.
That's my biology.
And he likes metal.
Oh, I did not know that. Okay. I'm going to test you on this one. Let's see.
How do you do the negative?
Oh, negative 3.
Ah. Some have already discovered something new that I'm throwing in.
4 and negative 8.
You know how to do everything that's on this problem.
I do?
Yeah.
That's awesome.
Okay, so we just did 2 methods. Let's vote which way we should do this one.
The part 2.
If you want,
Is that a negative 8 down
we're
there?
going to vote, allow people to vote. If you would like to us to do the green one versus the purple? You want us to do green? Raise your hand. That's like it. And the purple? Couple? Okay.
Me and, yep. I have 2 hands up.
So, we're going to take this 3, and we distribute it to everything, right? I like drawing these arrows so I see how many times I distribute. Is that good?
Wait, can we just do it the other way?
You forgot
Because
the
it
8, right?
seems so much
Thank
easier.
you. Thanks for noticing. What did I forget?
The 8.
I
The eight.
do mistakes on purpose. Sometimes I do them without, just because I'm an airhead sometimes. Other times I do mistakes on purpose to make sure you're paying attention. Let's write it all out. 8 to the 3rd power. R squared to the 3rd. Ladies. Q to the -4 raised to the 3rd power. G to the 6th cubed. B to the 7th cubed. Y to the -8 cubed. What's your neighbor? Find a neighbor, please. Complete the problem together. Stand up when both of you think you have the problem completed correctly, where all exponents are positive. The directions are, your final answer should have all positive exponents. Please simplify. Stand up when you and your partner think you have simplified this to where all exponents are positive. All exponents are positive.
I didn't do it. Can you elaborate?
Okay, find another partnership.
What life was it?
Okay, we have one partnership saying up. Thank you, ladies. Once you think you have this simplified, where all exponents are positive, please stand up. You notice people saying up here to you when you need some help. Ask them. They think they're confident. If there's people saying up next to you and you think you might need some help, ask them.
Okay.
Howdy, bud.
I got Frank coming up. I got this one. Get away! So I do, right. On this part?
Okay. Everybody your seats, please. 5, 4, 3,
I'm standing up.
2, 1. Lift your hand. Okay. These ladies are staying up first. Can you tell us what the next step would be from where we left it off at? When So we see double exponents. Let's have some of, whoa, what's that? Is are these two double exponents?
No.
No. Okay. So for the R, 2 times 3 is 6. For the U, negative 4 times a positive 3. Negative 12. Negative times a positive is a negative. Okay? What about 6 times 3? 18. 18, yeah, not adding. B, 7 times 3. And testing you again, negative 8 times 3. Negative 24. Great. Now, these guys in the front row, I know looked it up for us. This is not times, this is 8 raised to the third power. What did you guys get? 512.
Hey.
Is this good?
Yeah.
Wait, how'd you get 512?
8 times 8, 64. Times 8 again.
172.
Oh, is it not 512?
I said 512, you were like, no.
I don't know this one memorized. I have to look it up myself. 8 to the, it's 512. It's 8 times 8 times 8. 64 times 8. Okay. Okay, we clarified that? I looked it up. Good job.
We learned from mistakes.
Okay. Are we done? Thumbs up if we're done, or thumbs down if we need to do something else.
They're still negative.
Yeah. We should all be at thumbs down. And what's your name on the third row in the end? Aubrey. Aubrey, can you see anything for us to do? Directions, or let me restate the directions. Directions for simplify with all exponents remain positive exponents in your final answer. So what doesn't fit the directions that needs to be changed? Who's sitting on the floor over there? We have a seat available over here. And over there. Okay. Now that we're back to this, can you come find a seat? Thank you. What do we need to fix? The negatives. Good. Okay, so we have U for negative 12. Notice I circled both parts. And Y for negative 24. Where do those go? Bottom. Yeah, we can put all of this over 1. And the U will move down and the Y will move down. So our final answer, 512, R to the 6. So I can already tell the people when I do the same chart won't be sitting by each other. G to the 18th, B to 21st. Are those in alphabetical order? Let's try again. Let's try again. Okay. B to the 21st. G. Yes, thank you with my alphabet. Help me. And then alphabetical order, which one comes first for the denominator? Will it be negative 12 or positive 12? Positive, since we're changing location. That is the final answer. Okay. You put your phone away now. Okay, any questions? Make sure your answers are positive.
Do they have to be an alphabetical?
That's how it's going to be graded. So the person grading your given might be confused if they're not in alphabetical order. Okay, so I've already given you, by accident, the assignment, right? Yeah.